generally do this every week anyway, but obviously today when there's people missing, and okay, that's us now recording. So let me just quickly share the team first. So I'm going to quickly share this window. So if we go to our team here, I'm not going to change the graphic for that. If you go to the class notebook, this is something that really will be your kind of main resource as we go through this here. You can open this in your OneNote. So if you're in Office 365, it might look a wee bit clearer there, but you can open it there. Just go to Shared With Me tab, and you should see it there, and it should just say Student Azure Fundamentals 20A. But under the content library, that will generally have everything under resources. So under resources here, this is your general Microsoft Learn. I have added these two things, which are the kind of walkthroughs for going through the instructions. And I have added the 6 links to the Azure Fundamentals. We're going to do part 1 today. I would generally say it's probably better to do those parts before you come to the class, and then allow me to go over the slides, the main topics, and then it's probably better for you just to ask questions there. If not, just let me go over the slides first, and then you go through these chapters. It's just probably better if you do manage to, even if it's a quick kind of look through that, but if we look through that first, you will probably find that you will go through these parts multiple times, because this will be your main kind of resource for gaining that information. Again, the welcome pack information's here. How you validate your Microsoft student code if you haven't done that. And I've also got a link here. I'm going to put general links as we go through this. I won't show it right now, but these are study guides that have been created by other people. Maybe later on today or during the course, I'll go into a wee bit more detail on these, but I found these two, especially this first one, really good if there was a topic, especially when it came to doing the practice questions, that I would basically go here, do a quick read of it and see whether that gave me the answer. So you can have a wee look at that. What I've also done on here is I'm going to, for each of the sections as we go through them, create a number of sample questions. Now, I've got 30 for chapter 1 that you can go through as many times as you want. I'm not going to, there's no barrier on there. They are practice ones, but they're generally ones that I think are all good questions. And you should certainly know absolutely every one of these before going into the assessment. I have taken these from my experience of sitting the exam and from the kind of measure up ones. So what we should get in the next couple of weeks is codes to go and sign up for measure up. You haven't got that yet. I was going to do a demonstration of it today, but my actual voucher ran out, so I can't even log in myself. So once we get the new voucher sent out, I'll probably grab one and just give you a wee demonstration. But basically, a lot of the questions in there are really good practice for sitting the final exam. But what I will do is I will give you really focused questions on things that you must know. Generally, the really obvious parts of it, but also some wee obscure things that I came across during the course. So get used to having a wee look in here and make sure that you can see all of this, because it is really quite crucial as you go through it. But let me just upload the PowerPoint for today. And let's show the correct one. Now, the PowerPoints for me did not match exactly what you do in Microsoft Learn. So what I've done is I've taken some of the slides, about 8 or 9 slides, and moved them into this one here from next week. But what that does mean is next week you will, okay, I'm just reading some of the questions while I'm talking there. I will remember, if you don't know how to activate the voucher, that guide there is in the welcome pack and the validating a Microsoft code. So try and follow through that. If you can't do it after doing that, then just give me a wee shout again. What I would say is make sure you're not logged into Office 365. I generally used a different browser, or if you know your browser well enough, you can set up the incognito or private browsing so that it doesn't see any other account that you're logged in as. So when you register your new email, and again, it's for the activation for Azure, we're not going to look at Azure really until next week. So you don't really need to have done that probably. You've got probably 2 weeks to do that. What I might do is I have to register myself an account. So I might do all that next week and just show you me doing it live, and hopefully I don't make a mess of it, but I'll show you me doing it live. I'll activate my code, and that just shows you that I've got the exact same things that you've got. Now, this week, again, is going to be mainly me talking. I apologise for that. Next week will be a number of demonstrations on it. But this week, there's quite a lot of slides. I'll publish these slides on the OneNote, basically in the class notebook, once I've gone through them so that you can use them as a reference. But obviously, at this point, you can still come back and look at them within the video or the recording. So some of the slides I'll go through quite quickly, but this one here, the cloud concepts, it's one of the 6 chapters we go through, and in the exam you will get between 20 and 25% of your exam will be from this chapter. So a quarter of all of these. Okay, I'll have a wee look at that mix, sorry. A quarter of all of these, a quarter of all questions that you may get in your exam can come from this chapter. The lowest you can get is a fifth of all of your questions. I would also say once you study this, it is quite easy, not quite easy, but it's one of the sections that I think once you go through all of the questions, then you can almost get all of them correct once you've done a little bit of practice. Okay, so I'll again, for the people writing there, I'll go over that video again next week, and hopefully I get it correct first time, and I'll hold off from my registration. So again, this part here, you can have a quarter of all your exam questions come in here. So this is really, really crucial to actually know. And again, as I said, some of these sections I think are fairly straightforward, quick questions that you will get, and I'll emphasize that here. So there are one more section on here that I've kind of merged in, but we're going to cover the cloud models, the public, private, and hybrid. We're going to go through the cloud benefits and why we actually consider, or why you should consider going to the cloud. We're going to go to the services, IaaS, PaaS, and SaaS, and explain those. We're going to do the Azure architecture components, what are subscriptions, management groups, resource groups, and we're going to look at the kind of geography of Azure, which are things like regions and things like that we'll go into in a wee bit more in detail. But again, these are all the core things that we must know before we go into the section. So let's look at the models first. And we're going to define these. I'm not going to hang around on these pages too much. So the first thing we really have to kind of understand is, what is cloud computing? Cloud computing is the delivery of computing services over the internet, enabling faster innovation, flexible resources, and economies of scale. So the whole idea of this is having large data centers that are run by a company like Microsoft that we're focusing on, but that can also be Amazon's, Amazon, it could be Oracle's. There are so many different cloud platforms out there. All of the big companies have got them, from your IBMs to your Hewlett Packards, and obviously smaller companies as well. But there's a lot of these large data centers that are being created on or around the world, and because they've got so much computing power, and the advantages of having flexibility from our end. So rather than us thinking of installing a server somewhere, then we can quite quickly provision a server on one of Azure's data centers and have that up and running. Now, to give you a kind of example, so if we were working somewhere like the college and we wanted to set up a new Moodle server, what we would have to do is, one, we get permission to do that. We then cost that. So how much is the server going to be? What are the resources for the server? Do we need any licensing, obviously, for Moodle? We would have to do all that. Then we have to get somebody to install an operating system on that server, install any antivirus, any firewalls, and then install Moodle itself. Perhaps we use a default database, perhaps we connect to another database. But all of that takes time and purchasing and setup. So you're going to have quite a long time before that actually happens. Now, and an example that was explained to me probably a couple of years ago, and I think this was down in England. I think there was between 12 and 18 high schools. It was decided within the region we're going to get a Moodle server. So one of the options was to install Moodle and to install a server in every single one of the schools. So that would be 18 servers. If you've got 18 schools, would have to get that installed. So you purchase 18 servers. You have to get your operating system and have these all configured, updated, and so on. And then you have to find out where on the school you're going to place that and do all of the normal configuration. But a year down the line, how many, you then work out how many schools are actually using Moodle, and you find out there's only 6 schools using it. So you've now got 12 servers that are not being used, that you're paid for, that you may continue to pay for, but what you need to then do is decide what you're going to do with them, because it's been a big waste. But likewise, you might have rolled out 18 and then decided actually there's another few schools that we want to bring on, and we have to go and buy additional hardware. What you can do in the cloud is you can purchase big enough resources, so a really good amount of CPU and memory power, and roll out a Moodle image, probably within about 5 minutes. Then you can connect all of your schools to that Moodle instance. And you could do this very quickly without a huge amount of effort. Most of this is actually scripted, and you just choose Moodle from one of the scripts. That way, if we have enough resources to run against the 18 schools, and a year down the line, you only have 6 Moodle schools using Moodle, you can reduce all of the resources that you've paid for, and without the headache of getting rid of 12 servers or anything else. So the cloud gives us this great flexibility that we really don't, or it's expensive to get, and you can be left with a lot of expense if you don't use that. And what we'll be looking at as we go through that are other examples of that, but also the kind of main advantages of it. There are 3 cloud designs that you must know. You will highly likely get at least 1 or 2 questions on the 3 terms here. The first one being the public cloud. This is owned by a cloud services or a hosting provider. So for us, the one that we're looking at is Azure and Microsoft. Provides resources and services to multiple organizations and users. What that means is where we build our own data center, for example, in a college, then we own that. It's ours and we use that. Microsoft Cloud and Azure don't build that for us in particular. They build it for anyone. So they've got the advantage of being able to scale this up to something very large and allowing them to sell that or chunks of that or parts of that to organizations and individual users. It's accessed via a secure network connection, typically over the internet. Most of us that connect to Azure will do that over the internet. If you're a larger company or want to pay for a lot better connection, you could have a direct fiber link to your nearest Azure kind of cloud, and obviously you'll get a far better performance. But obviously that's generally for larger companies that would require that greater connectivity. But that's the public cloud. That's basically Azure, where all of the resources are online, or should I say, in the cloud. Then you've got your private cloud. Organizations, should I say, create a cloud environment in their own data center. Organization is responsible for operating the service they provide and does not provide access to users outside of the organization. Now, you still can do that. You can still give people, but generally everything in there is yours and for you to use. You will still provide services like Moodle and web servers that people outside your system will use, but they will not be running their own services in your data center. It will generally be for you. One of the things about the private cloud, it's still internal, and nowadays you can get Azure and have it installed internal to your server, so it will still look like Azure. Internal to your site. You can still use the portal, but one that points to your own cloud, and it will still work through the portal, but it will be only you that has the access to that particular infrastructure. Again, the services on it can still be accessed externally, but it will only you that will have that. So unlike the kind of public clouds, which deliver services to multiple organizations, a private cloud is really dedicated to the needs and goals of a single organization. So ultimately, a private cloud is a single tenant environment. We don't have anybody else that will be using the cloud for our systems. Again, if there's any questions or any comments you want to make, feel free to unmute and just ask them. Otherwise, I'll generally keep going as we've got quite a few slides to go through. So we've got the public and the private, and we'll expand more on what we should know about these as we go through it. So this is a general overview. We've then got to the idea of a hybrid. The hybrid ultimately is when you've both got a public and a private at the same time. So you may have certain things that you're not ready to move to the cloud yet, but you still want to run them in a private cloud. So you basically do that. But at the same time, you also have a public cloud, and you can have both of these linked up so they act like one cloud. And we'll explain in more detail as we go through the course how we do that and some of the key terms that you must kind of understand, because questions do come up on those. But ultimately, a hybrid cloud is when you've both got a public or a private. Now, annoyingly, I was going to ask a wee question in forums, but for some reason, it's not giving me the option to add that. If you're starting your cloud, do you start with a public or do you start with a private, or does it not matter? I would have done that as a question, but you can put that in chat or you can answer on mute. So if you're starting your journey in the cloud, do you start with a public or a private, or does it not matter? Just watching just to see when the answers stop. Okay, and I think there's generally there's the one answer to this. It doesn't matter. You can start with private or you can start with public. It doesn't matter. It depends on your business requirements. So if you haven't got an internal data center and you haven't got any infrastructure, you can decide to go that way first and then go public, or you can decide to go straight public cloud and then later on have a private cloud for something that you really don't want to be stored on the cloud, or there's an actual requirement for that. And what you're just on what Sammy's saying there, will private cloud not cost more than public? Yes, and I've got a wee chapter, or I've cut 2 slides on that later on, and I'll go into more detail why that is, and there's a couple of key terms to learn there. But obviously, when it comes to your private cloud, you've got to pay and invest in all of that infrastructure. So there's a huge upfront cost to do that, and we'll go into a wee bit more detail. But it doesn't matter. You don't have to start with either a public or a private. And I'm sure I've seen a question on that within one of the exams that it says to have a hybrid exam, a hybrid, you must start with a public or you must start with a private, or it doesn't matter. You can start with either. So it's one of these wee things to keep in the kind of back of your head. So ultimately, public, private, and hybrid. So in the public, no capital expenditure to scale up. In other words, we don't have to buy the hardware. That's really what it is. And we're not just talking about hardware there. You need rooms, you possibly need cooling, you need all the hardware for the security, all of those things there. Applications can be quickly provisioned and deprovisioned, so you've got greater flexibility. Organizations pay only for what they use, whereas a private cloud, hardware must be purchased for startup and maintenance. Organizations have complete control over resources and security, and organizations are responsible for hardware maintenance and updates. And then hybrid obviously provides the most flexibility. Organizations determine where to run their applications, and organizations control security, compliance, or legal requirements. So ultimately, you have to decide what you have. Most people will have some kind of private infrastructure to start with, and then it will go to the cloud. But if you're a startup, then you may make that decision just to go straight to the cloud at the start because you don't have that infrastructure or don't want to pay for that initial infrastructure. So some of the benefits that we have on the cloud. So we're going to identify them. I'm not going to describe that since I'm going to go through every one of these here. All of these terms, I think you should be familiar with, or certainly most of them here. And let me, let's see if anybody wants to have a wee go. What is high availability? I don't know if anybody wants to unmute or if they want to type, but what does high availability mean? Yeah, available 24/7. Now, or as close as 24/7 as we can basically agree. Now, as you go through the course, you will see there are standard, what's known as an SLA, a service level agreement. You'll have a standard SLA. If you pay for I think it's the basic support is the minute you can, or the lowest that you can go for. In fact, we will look later on the different kind of plans there are within Microsoft. There are plans that you don't get SLAs, and there's the absolute minimum one that you do get an SLA, but you can also get better ones if you pay more. But you'll see the standard SLAs and how we can improve on that and what the uptimes are. Now, the ones that can be a wee bit tricky are scalability, agility, and elasticity. Let's start with scalability. What do you think scalability is? Yeah, and there's lots of good answers there. Now, when we look at scalability, we can look at it in 2 ways, and we can look at it something called vertically, and that's when we increase things like the memory or the number of CPUs. So you've got one kind of machine, but you increase its performance level. Horizontally, or is when we look at the computing capacity, can be increased by adding instances of resources. For example, if you've got a virtual machine that's running, but you've got high demand, then another virtual machine comes online to support that demand, and that's known as horizontally. So we don't increase the performance of any single machine, we just add more resources to help with that work. So scalability, as people said there, it's the the ability to grow, increase performance, all of these kind of things there. The global reach, well, ultimately global reach, in this case, I'll explain this one here. This isn't one that I think you would ever be asked, so that's why I'm kind of not pushing on this one. It's really just the kind of availability around the world where you can play something. So anybody in the world can access any, and I think this is correct, apart from maybe China, I'll need to double check there, can access any data center or access anything that's stored on a data center. Ultimately, you want to try and store things that are close to your customers. You may also want to store things in multiple regions to get closer to more customers, but you've got that full global reach. Now, one that's perhaps not as easy to explain. Anybody want to have a go at trying to explain what they think agility is? Now, speed of what? Uh, yeah, I think that's Mohammed's got Shahid Rafiq has got a really good adaptable according to needs is probably good and easy to change direction of development. Yep, Eddie, that's a good one as well. Basically, cloud-based resources can be deployed and configured quickly, and applications as basically application requirements change. So you've got the ability to change and push things out very quickly. So for example, if you decided that, wait a minute, I've got a virtual machine running a web server, or should I say maybe an application, or I'm running applications out of the UK, but all of my customers are based in South America, you could quickly move all of those services to South America without much problems. Obviously, if they were physical resources, that would be a hugely difficult a task, but it gives us the ability to change things very quickly. And that might be downsizing. We may have basically paid for a lot of resources and don't need them, and we can quickly push those resources down. So that's what agility is, the ability to quickly change as whatever you need. We've got two things here, disaster recovery and fault tolerance. Disaster recovery is basically backup, where we can back up our data, and if anything goes wrong, we can restore that very quickly. That is ultimately what disaster recovery is. Fault tolerance is basically keeping your resources running. So it goes into the kind of high availability. But fault tolerance, other than just things like high availability, there's not a lot of difference between high availability and fault tolerance. But what fault tolerance can do is things can automatically change. So as part of our infrastructure goes down, then quickly and automatically the Azure can switch to other resources, either in the same region or different regions. And I would think high availability and fault tolerance are almost the same thing. Elasticity. This is one that I saw getting asked quite a few times as I went through it. Anybody know what elasticity would mean when it's cloud-based? Yep, and that's pretty, Shahid, again, that's pretty accurate there. So elasticity is when cloud-based applications can be configured to take advantage of things like auto-scaling, so that your application will always have the resources they need. So for example, say that you find out during the kind of night time, maybe from, for something like the college, it might be from 9 o'clock to 9 in the morning, that a lot of the equipment doesn't get used, or a lot of the services or processes don't get used very much. But suddenly at 9 o'clock till 11 o'clock, they get used a lot. Elasticity will basically mean that other virtual machines, for example, will be turned on to meet that demand. So they will not have to be managed by a particular user, but they will be turned on automatically to increase your performance, and likewise turned off when the demand is not there. The whole idea of that being that you don't have to pay for the resources when they're not being used, or pay a lot less when they're not being used. But when you have that demand there, you don't want your customers or users to be penalized by a really slow kind of interface. And all of these will automatically come up to meet that demand. We've got things like customer latency capabilities now. One of the things we should be aware of is latency when we get into some of the more specific things here. But latency is obviously, or not, we don't know if it's obvious, but it's the delay in gaining access to your data. So the biggest thing for us for latency is obviously the speed of our connection and the closeness of the data. So if we've got people all around the world accessing our data, we may not want to store it in one single region. We may want to replicate that across multiple regions. Predictive cost considerations, well, I'll just explain this one here. What we should be able to do is to try and get a rough idea of how much something's going to cost us. We've got a chapter on this as we go through, and we'll spend a bit of time on looking at, well, how do we know how much is this going to cost, and how do we know how much we're currently paying? Then we've got security. Now, we'll talk more about security as we go through, but you've got a couple of types of security. One, physical security. The Microsoft will obviously look after most of your security considerations. The physical security they will look after, and we've got things like firewalls that Microsoft will have, and firewalls that we can configure on Azure. Now, of these terms, the things like high availability, fault tolerance, elasticity, scalability, agility, and disaster recovery, you must be able to have a rough idea of what they are. So during your test or practice test, it will say something like a statement and say, which one of the cloud benefits is this describing? Now, in most of them, I found them to be quite easy, these questions, but there's the odd question you think, well, is that agility or elasticity? And it can be a wee bit tricky from that point, but obviously the greater understanding you have of these terms, the easier this is to basically match up a description to. Now, this was something I said earlier on that I would come to, and you must know the difference between capital expenditure and operational expenditure. You will be guaranteed to get at least one question on this, and again, these questions are generally very easy. So as long as you know what these are, but capital expenditure is the upfront spending of money on physical infrastructure. Costs from capital expenditure have a value that reduces over time. So capital expenditure is ultimately two things: the purchasing of your computer and hardware. So you're going to have to buy your computer, your routers, your all of the kind of communication media, your cables, etc. But you're also going to have a building that is going to actually be built, or somewhere that you can store and set up there. All of this is your capital expenditure. Then everything that's not that is your operational expenditure, spent on products and services as needed and pay as you go. You get billed immediately. So operational expenditure is basically the cloud. When you rent services from a provider, capital expenditure is the money that you have to basically spend to set up your physical infrastructure. Now, you will see later on, we've got calculators that we can use from Microsoft to try and compare both of these. It's not an exact comparison, but it will give you a rough idea of the different costs. But you must know the difference. So, for example, an exam, it might ask you something like you're building your own data center to store a number of applications. Is this an example of one of the following? Capital expenditure, operational expenditure, and it will say another two things that are got no link to this at all. But these tend to be quite easy questions. So make sure you know the terms capital and operational expenditure. The cloud is basically known as what's basically stated as a consumption-based model. Cloud services providers operate on a consumption-based model, which means that the end user only pay for the resources that they use. Whatever they use is what they pay for. You get a better cost prediction. Prices for individual resources and services are provided, and billing is based on the actual usage. So in other words, there are no upfront costs. So if the college, for example, decided to set up Azure, or if a user sets this to set up and configure Azure, there is no difference in the initial costs. You basically get some kind of agreement and setup. We'll look at a wee bit more details, a subscription for somebody to use the resources. And it's only when you use those resources you pay for them. Now, a wee caveat to there, if and we'll go into this in more detail as we go through the course, but if I set up a virtual machine and nobody connects to it, there will still be a cost associated to it, because the actual storage of that image and the data on that virtual machine will cost something. So you'll have to pay. Now that might be, 0.001 or 0.005 pence of the cost to store that. It might not be a lot per hour, but obviously there's still a cost associated to that there. So don't think by not using a service it will not ensure a cost, because it will. And even turning off a virtual machine, you still have to pay for that storage. Obviously the cost will be greatly reduced since it's not running, but there will still be a cost there. And I think, as Andrew said last week, the one thing that you have to discipline yourself when you're on the cloud is, especially for you with, I think it's 100 credits you get, £100, is when you're not using something, turn it off. If you're finished using something, delete it completely, and then you will not assure any costs. Now, obviously the costs here are against your own credit, so it will never cost you real money on this, but you don't want to burn all your credits up before you get to the end of the course or a chance to practice with everything. So make sure you do understand capital and operational expenditure, and the idea of the consumption-based model. We've got a number of services here, and I'm going to go through the three of these, and I'm going to go through these again and again as we go through this course. There are three things that you have to know, and I'll do it in the order you really should know them. IaaS, infrastructure as a service; PaaS, platform as a service; and then SaaS, software as a service. You must know those three terms. You will get at least one or two questions. I would almost guarantee you'll get two questions in the exam on this here. And again, in most cases, this question, once you've learned it, is actually quite easy. So what does infrastructure as a service mean? And what does this slide say? Well, it says build pay-as-you-go IT infrastructure by renting servers, virtual machines, storage networks, and operating systems from a cloud provider. Basically, infrastructure as a service is the same idea as you've got complete control of everything to do with one server or more servers. What we see on this slide here, across this part here, is everything that the cloud provider, and we'll just say Microsoft or Azure here, would actually provide. So this is the things that they do, and you do everything else. So they'll look up, let me go back a page here. They will look after the servers and storage. In other words, they will physically install the servers in some data center, and they will look after all of the storage mechanisms. You don't have to worry about where they are. You know, are they secure? Are they looked after? Microsoft will do all of that. Microsoft will look after the default networking, firewalls and security. You will still be able to configure these, but Microsoft will have all these installed and set up. You can set up your own networking and you can configure the firewalls as you go on, but Microsoft will provide these. And the data center, the physical building, are all supplied by Microsoft. All of the rest you do. In other words, you have to install the operating system, configure the operating system, patch it, update it, install the software, run the services. You do everything else. This one here is the one that a lot of people will do at the start before I think they get their head around what the cloud provides. So IaaS, you do everything other than the physical hardware ultimately. And you must know that. Then we've got platform as a service. Now here, notice that platform as a service, Microsoft do more. They look after the operating system and they look after the development tools, the database management, the business analytics. They provide all of that. So in platform as a service, we don't, in a lot of cases, care what the operating system is. We simply go to Azure and say or configure, for example, an application to run on a web application to run on Azure. We don't care if that's Windows Server 2016 or 2019 or whatever. All we want it to do is to configure, or what we'll configure is Azure to run that application. So anything that runs things like a web app or like a database server, so Microsoft will have installed the database server, done all of that. All you do is you configure the database the way you want. So that's platform as a service. And the way infrastructure is Microsoft look after infrastructure. Platform, you look after everything that you want to run, but Microsoft look after the operating systems. So in other words, there is less for you to do on the platform as a service. Then we have software as a service, and software as a service, basically Microsoft do everything. They will install and have the services running, and the services in this case being things like Microsoft Office 365, email, calendars, but it also includes things like Skype, you know, Microsoft Dynamics, CRM Online, all of these things here. Now, what Microsoft do is they develop that, they upgrade that, and ultimately all you do is you configure that service. So you don't care anything else. All you do is you connect to the interface for that service, and you configure what you want your users to be able to do. So you may decide that some of the services you don't want them to be able to use. There might be some services you do, but you're in complete control of what the end user will be able to do. But you don't install it, you don't uninstall it. Microsoft do that, and they will continually update that. You just configure what you want your users to be able to do with it, what you want them to be able to see, and so on. So that's IaaS, PaaS, and SaaS. When I looked at these terms over the years, I never really got a clear picture in my own head what the differences were. And when I started this course, I always wondered, you know, will I actually remember what all of these are? Well, I'm quite clear in my own head now after going through this course. So all of these is for the public cloud. Every one of these. So Sammy, every one of these is for the public cloud. All of these run on the public cloud. So on IaaS, ultimately we would pay for a virtual machine and we would install the operating system and do everything else. So other than actually dealing with the physical computer, we do everything else there. So that's the closest to what you would be doing if you kept everything in-house, except you don't look after the hardware. Platform as a service, you don't even care about the operating system. You will put things on top of an operating system, like web apps, databases, and you will control those. And then on SaaS, you don't even care about any, you don't even care about installing or doing anything. All you do is configure services that will work for, that you want to push out to your end users. You're guaranteed 1 or 2 questions on this, so you must be able to follow that. And I generally found after going through a few questions that this generally stuck in my own head. So IaaS is the most flexible cloud service because you've got complete control of it, but that might not be what you want. You configure and manage hardware for your application. So you set up how much memory you're going to do, what operating system and so on. PaaS, platform as a service, focuses on application development. Platform management is handled by the cloud provider. So you don't care what that's hosted on. You will simply upload your application to the web and state what how many occurrences, where it's going to be, and so on. And SaaS is pay-as-you-go pricing model. Users pay for the software they use on a subscription model, so for like Office 365, etc. This is an overview one, and I've got a slide. I thought about putting it on where somebody done called pizza as a service and explained it with pizza, but when I looked over it again, I thought it was slightly confusing. But ultimately, the green part you manage. So on your own private cloud, you manage everything from the storage, networking, all the way up to the data access and applications. You've got complete control. So when we go to a cloud model, you'll see you give away aspects of that control. So infrastructure as a service, we don't care about the storage, the network, and not to say we don't care about it, but we don't manage it. The compute, the processing and everything, we don't care about that. All we do is we install the virtual machines, the operating system, and everything else. Whereas this platform as a service, we don't care about the virtual machines, the operating system, or the runtime. All we care about is the application and data access. Then software as a service, it is simply the data access that we look at. So as we can see, as we go across this way, we can see that we give up more and more control because sometimes you just don't want to be the person that's going to manage that. You don't want to manage virtual machines. It doesn't matter to you. All you want to do is to have an application run, whether it's a web app or something that provides functionality to mobile apps, etc. I think that's the last part on that. Yeah. Any questions on that? And I do think it's something you'll probably have to read over a few times before you become a full understanding. But I would say that remember it that way as giving it up. So this is the operating system and virtual machine. This is your apps, basically, and this is just configuring services for your users. But any questions on that? You will have to go away and learn that to be completely aware, so that no matter how you're asked for it in the exam, you will hopefully be able to answer that quite easily. I don't see any questions, so I'll carry on, and hopefully not everybody's in a power cut. I'm not going to get a lot of detail with this right now because we get into the 2 things below in more detail as we go through the course. But there's a thing we now get into, something called serverless computing. With serverless computing applications, the cloud service provider automatically provisions, scales, and manages the infrastructure required to run the code. Now, when we say serverless computing, it doesn't mean that there isn't a server there, because there is. There's a server still running at the back end of the services here. It's just that we don't see it. All we're caring about is running the applications that we want to do and not worry about the underlying server. There is still servers, but we don't see them. There are two things that we will cover as we go through. We've got something called Azure Functions. We don't create these. We don't actually have to know much more than what's on this slide, other than a wee bit more so that we know how to answer the questions on it. But Azure Function is code running your service and not on the underlying platform or infrastructure. It creates infrastructure based on an event. So you create a function. Now that function may be to react to something in your environment. It goes and runs and then stops. So maybe if something's running out of space, it finds that event, it generates, some kind of something you want it to do, whether it cleans up something or does something, it finishes, and that's it. Then you've got Azure Logic Apps. Now, there is not a huge difference between functions and logic apps, but it's a cloud service that helps you automate and orchestrate tasks, business processes, and workflows when you need to integrate apps, data, systems, and services. What Azure Logic apps normally do is they normally create things like workflows, where one logic app feeds something onto another logic app. Functions tend to be one-off events. Azure Logic apps tend to be things that kind of feed through a workflow. And that's all I'm going to basically say about that right now, because we do go into more of the kind of details. Now, we're going to, again, cover a couple of other topics here. This was meant to be, or was on my PowerPoint for next week, but it's one thing I was told a wee bit unsure about from Microsoft, but everything that you do in Azure One on the Microsoft Learn is included here. So I just wanted to make sure we cover it today. But what that means is next week there's very little to go over from the point of view of PowerPoints. We'll just be going over a number of things within the Azure portal and not kind of a lot of the theory that we do here. Now, Azure offers more global regions than any other cloud provider with 60 plus regions. Now notice that a region doesn't mean something like a continent. There is no link up to that. So a region is a geographical area. So what that means in somewhere like North America, there are multiple regions there. I changed the slide that was on here. This is continually being updated as Microsoft brings on. I think this is the latest one that I found, as Microsoft kind of increases their capacity. I can't really see it, but the wee kind of blue glows here are all of the data centers around the world. Obviously, North America and Europe have got the most, but you can see all continents have I'm not sure how what the differences between them are, but Microsoft that I know of is really impressive. Obviously, AWS is quite a big one as well. Although this slide does say that they offer more, so I'm going to take that on its word. Now, these dotted lines, they might not be that easy for you to see on here, but things like all of these dotted lines are fiber communication channels that Microsoft either own because they put it down, or they rent off of somebody because somebody else put that down. But what you can see here is all of their data centers are interconnected with other data centers using this fiber backbone. So Microsoft have spent a huge amount of money putting down this fiber backbone across the world so that they have really good bandwidth and latency between their data centers. So we're going to cover, or let's look at the term regions. Regions are made up of one or more data centers in close proximity. I found going through some of the questions that sometimes this wasn't always clear, but we have to take this at face value. Nearly all regions have got more than one data center, and I would imagine at some point all regions will have at least 2 data centers. But as Microsoft say here, regions are made up of one or more. So when you get asked this question, you've got, if you got asked this question, you've got to say or think one or more data centers. Now, in close proximity, so when we set up a region, we want data centers that are close to one another. So you might have things like, West Europe, South Europe, and so on. Preserve data, provide flexibility and scale to reduce customer latency, and preserve data residency with a comprehensive compliance offering. And I'm not going to get into a lot of detail on that part here, but we're going to get into these terms a bit more. But again, remember this part here. Regions are made up of one or more data centers in close proximity. And remember that in somewhere like North America, there are multiple regions there. We get something called region pairs. This is another term that you must know because you're probably going to get a question on it. And a region pair, there's at least 300 miles of separation between a region pair. In other words, we've got one region and we've got another region that work really closely together, and we have at least 300 miles between them. Why do you think we want at least 300 miles between them? Why do you think that's specified? Yes, natural disasters or some kind of local problem that that could be flooding, could be windstorm. These are all natural disasters. But if we've got 300 miles, then we're hoping that there's not going to be an event that's going to take out both of those regions at the same time. So, for example, we've got a region called UK West and we've got a region called UK South. These are paired together. Now, what that means is, and I think it goes into a bit more detail in this later on, that data that requires to be replicated in UK West will go to UK South and vice versa. That means if we lost the entire region of UK West, then the connectivity to UK South would be able to provide that is data or everything that was in UK West that was required to be accessed in that different region. Now, we don't link UK West with South Central US because that's too far away, and the cost of replicating all of that data would be too great. It would also increase the latency for any customers. So what we look for is to have these relatively close together, but greater than 300 miles. So in reading this here, automatic replication for some services, so not everything will be replicated. Prioritize region recovery in the event of an outage, and updates are rolled sequentially to minimize downtime. That's quite an important one as well. So if you're running an update, you do not run an update on UK West and UK South at the same time. You will do UK West or the other one vice versa first. That way, if something goes wrong, we can go back to our region pair and continue to access our service. Once that one works and is seemed to be working, we'll then upgrade UK South in that order. So you can see these are special regions that have been joined together to help on this idea of kind of redundancy. Not every single region has a pair. So lots of regions are paired, but not every single one currently has a pair. We've then got something called availability options, and we'll see in a second availability zones. If you install a single virtual machine, you will get an SLA of 99.9%. So what we are saying is, in a month, you will have a guaranteed 99.9%, but the guaranteed. Your service level agreement will say that you should have a 99.9% uptime. What happens if you don't get that? So what happens if there was, you didn't get your 99.9% uptime? Can anybody guess what happens? you get compensation. The compensation from Microsoft is in the form of credits, like what we have talked about, or what you get when you go on this course. You will get credits. They won't give you money, but they'll give you credits. In other words, they'll take money off of the services that you use in the next month, but they won't actually just give you money. It's just all based around a credit system. Now, if 99.9% isn't good enough for you, then you can go for something called 99.99%, and that's done through availability zones. So this is a single VM installed in a single data center. We've got something called availability zones, which basically means that rather than just have your one VM on one location, you also have it somewhere else. So if there's a failure here, this one here will basically take over. So protection from entire data center failures. Then if you want something even more than that, because this is could be built around one region, but you could have a complete region failure, then you can look at region pairs. And after that, you can increase to 3 nines. I think they generally call it 99.999 or beyond for your uptime. There's regional protection with data residency boundaries. So these are the kind of availability options that we can get. This is the cheapest over here. This is more expensive, and this again is the most expensive option of the three. You would have to decide, is 99.9% suitable for you, or do you want to pay for a greater amount? And that's really down to your own business requirements. Now, we mentioned things like availability zones. These provide protection against downtime due to a data center's failure. Physical separate data centers within the same region. So what we will have is, if something's powered, one of the data centers is powered and the power goes off, that other data center in that region isn't on the same power or has its own power, and it can carry on working. Each data center is equipped with independent power, cooling and networking, and connected through private fiber optic networks. So Microsoft will either roll out or it will purchase fiber networks to interconnect these availability zones. So typically we can have in one region 3 availability zones that will closely work together. So if anything goes down, the other one will pick up that workload. Now, I saw this on one of the kind of events that I was on. This is the latest Azure data center in Dublin, Ireland. Now, what I would like to say on this here is a couple of things. This here is one data center over here. This here is another data center. In fact, that whole building. And here is another data center. So what has happened in just this one Azure data center is they've split it up into 3 data centers. The whole idea of that being that they're all independent. All right, do you not see the red line when I do that? Oh, that's a wee bit annoying. Okay, so yeah, I didn't know you couldn't see that there when it does it. Okay, so the one on the left, okay, I wasn't aware of that. It's a bit of a shame. But the white buildings on the left are one data center. The big blue building in the middle is one data center, and the blue building to the kind of top right of that is another data center. That's a bit annoying because being able to label these is a wee bit better. So this is split up into 3. So even on this one large Azure site, they've split it up into 3 data centers so that if there was ever a problem in one, then hopefully it will not affect the others. Notice as well on the kind of right-hand side, you've got with a lot of power generators, and all of these are I think everything on the right-hand side is to do with generating its own power if the kind of national grid went off. So it's purely,
Alan,
yes.
see, you discussed earlier about availability zone. So these are 3 availability zone.
The availability zones tend to be on different ones, but yes, these work as 3 availability zones. So
Okay.
they are completely. So say there was a fire on one of these here, there's enough separation between them that the other 2 should be able to work without even if it was your virtual machine was on fire, it should be able to switch to another virtual machine in the other data center. So they're physically separate, but they could still be on the same site. I've never seen a question as specific as that, but yes, that would be it.
So basically, this is a 1 region and 3 available zone.
Yes, in this one diagram. You might have these a lot further apart, but it will still work under the same thing. Now, obviously, it's a lot easier if I've got them close together, since we don't have to run too much fiber between them all, but they are still physically separated. Just to help protect anything that could go in here. But obviously, if there was a natural disaster here, the 3 of these would go, but that's where a region pair would kick in, and it would connect to a completely different region over 300 miles away. Okay. Now, annoyingly, I can't show this, but do you see the roundabout at the kind of bottom left there? Why do you think there's a roundabout there? When there's only 2 roads, there's only 1 road to that roundabout and 1 road away. Why do you think there's a roundabout? What traffic would you, if there's only 1 road there, what traffic, why would you want a roundabout?
Slow traffic down.
Yes, to slow traffic down. So why do we want to slow it down? Well, to stop any potential attack, like somebody ramming a truck into the data center. So what would happen is it would have to slow down. And now notice if you go through that, going towards the building, there is a turn of about 60 degrees turn that you have to do to drive towards the car park. All of this is deliberate so that anybody who wanted to try and gain speed would be greatly restricted on doing that. So you also notice there's a fencing and all the way around the building. Nobody's allowed access to this complex, and only obviously staff can get into the building. But all of these things are thought out so that people cannot or greatly reduce the chance of any physical problems at the particular site. So there are loads of these sites being built. The other thing is, if you look at the size of a car on this picture to get a rough idea of what size this data center is, because I think sometimes you look at this and think, well, that doesn't look that big. But if you look at the size of one of these cars and just look at the size of this data center, then it is absolutely huge. The closest one to Paisley is UK. It's probably UK West, but the ones in Ireland are not that far away either. So for the college itself, it hosts its website on a cloud, and it's hosted in Ireland, one of the Irish data centres. So, and this is something we're going to look at a lot next week, so I'm not going to spend much time, but Azure resources are components like storage, virtual machines, networks that are available to build cloud solutions. So a lot of the times for us will be things like virtual machines, app services, SQL databases, functions, and we may kind of create virtual networks to allow particular things to talk and other things not to talk as we go through it. But virtual machines and app services and databases are probably going to be the biggest things that we look at. And obviously next week we will look at in a bit of detail how we do that on the cloud. Now, just on that question there, because there's the UK West is in Cardiff, is it? So it's probably going to be Cardiff or one of the Irish ones is the quickest that we have. There's another question I think I was going to say there. I've completely forgotten what it was now. Triggered something that Liam said there. Okay, I'm sure it'll come back to me. But Azure resources are what we're talking about there. Things that we will build within the Azure portal, as we'll see from next week. Now, these again are terms that you must know. A resource group is a container to manage and aggregate resources in a single unit. Resources can exist in only one, right, in fact, let me just stop there. So a resource group ultimately is like a folder or a directory. It's used to help you organize things. So what you can do is you can put resources in there. So you could put multiple virtual machines. You could put an AI instance. You could put storage in there. You can put a database in there. You can, anything that you have has to be associated to a resource group. And to help organize that, we have resource groups. And we place our items under there. So like you would do in a directory or folder, you think out, well, it'd be far better if I've got a folder for maybe my Word documents, or a folder for this project, or a folder for HR staff. You would do the exact same for resource groups. And you put all light resources under there, and it makes it a lot easier to manage going forward. Rather than have all of your resources under one resource group, you split it up to make it more manageable. Then we have these 4 points. You must know these 4 points. Resources can exist in only one resource group. So if you've got a resource of one virtual machine, one instance of a virtual machine, it can only be associated to one resource group. It can't say, I want that in that resource group and another resource group. It can't happen. It can only ever be in one resource group. I have seen this question during the exams, and it will say, can a resource be in multiple resource groups? The answer is no. So it's one of these to remember. You can have another instance of a virtual machine in another resource group, but not that same instance. Resources can exist in different regions. So if you create a resource group, you could have one virtual machine in UK West, and you could have another virtual machine in what was it? North America East, or something like that, or one of the Asia South, one of these ones here. It could go anywhere. So a resource group doesn't care where the regions, where the resources reside in regards to its region, but we don't have to worry about that. But we must remember that they can have multiple regions in a resource group. In other words, a resource group is not linked to a particular region. Again, I have seen questions on that. Resources can be moved to different resource groups. So if you decide that you want to move a resource to another, it is better maybe been managed by a different team. You can move that resource from that one resource group to another. Again, question I've seen come up before. Applications can utilize multiple resource groups. So if you create an application and you need a resource like a database, then it doesn't matter which resource group that's in. The resource group is to manage or to have better manageability of the resources, not for access to the resources. So any application does not see the resource group that the resource is in, it simply sees the resource. Does that all make sense? Because when I went through the practice ones, I went through a mixture of the practice and exam I saw questions in every one of these here. And to be quite honest, again, I don't think these are hard. So it's a case of just memorizing these here. And then if you get a question that says, your company wants to access a resource that's in a different resource group than the one you manage, is this possible? The answer is yes. It doesn't stop you. It just means that you can't manage the resource, but you can still access it. I'm not going to get into a lot of detail on this right now, but the Azure Resource Manager provides a management layer that enables you to create, update, and delete resources in your Azure subscription, and I'll get into a wee bit more of Azure subscription there. So we've got a kind of number of different interfaces. We can go to the Azure portal. You can use Azure PowerShell. You can use Azure command line interface, and you can use REST clients. All of these will speak to the resources or to eventually the cloud, and allow you to manage your resources ultimately. It will control all of the authentication and the authorization for which resources you've got the rights to manage. And I'm not going to, we'll get into a lot more detail on Azure Portal, PowerShell and CLI as we go through. Just kind of keep that in the back of your head right now. Now, this is the one part that you don't really get much chance to play with as you go through the course. It's really just a case of kind of learning a wee bit about them. An Azure subscription provides you with an authenticated and authorized access to Azure accounts. Billing boundary is ultimately to generate separate billing reports and invoices for each subscription. And access control boundary is to manage and control access to resources that users can provision with specific subscriptions. So what the two things at the bottom basically mean is you might want to separate your subscriptions into billing areas. So what we mean by that is, for example, if you've got your IT that looks after infrastructure, you might have a subscription there called infrastructure that you want to generate costs associated to it via that subscription. And you might split up your subscriptions down to things like departments or sections so that you can have a clear view on which ones are generating which expenditure. Or you may just want to have it as an access control boundary. Okay, I want a subscription that allows me access to all virtual machines. I want a subscription that accesses me to all services, and you control it that way. Or you may have a mixture of both. And I'm going to give you a slightly better slides on this. And this is how it is managed. Now, I'll read the one on the left first. Management groups can include multiple Azure subscriptions. Subscriptions inherit conditions applied to the management group. 10,000 management groups can be supported in a single directory. And a management group tree can support up to 6 levels of depths. Now, on the slide on the right, you can see there's only 4 levels shown there. So what does that mean? Well, you've got your management group at the top. A management group can contain other management groups. So think of it as folders. You could have a folder that says office work, and then you could have 3 folders inside that says spreadsheets, Word documents, things like that. Management groups are the exact same idea. You can have different levels of hierarchy within management groups, but remember, you can only go up to 6 levels of depth. It's not unlimited. Then under management groups, you have your subscriptions for how you're going to organize that. But ultimately, in fact, a wee slide on a subscription, I'll go into a wee bit more detail. Under a subscription, you can have 1 or more resource groups. Remember, a resource group is just a name of a container that will store your resources. So you could have one called VMs here and one called, web apps. And then underneath your resource groups are where all of your resources connect to that. This one here I thought was a better slide that I had access to. So we've got our root management group at the top. So that one there, everything that we do there affects everything else. So if you look, we've got 2 subscriptions, EA subscription and EA subscription on the right-hand side. Both of these come directly from the root management group. So anything we've set there, they will pick up. So at the very top there, you want to set something that affects everything in your organization. That might be compliance rules that you want. And we'll explain, we've got a chapter on that there, on what they actually give. But then we can fine tune it. So for example, we've got a human resource one, an IT one, and a marketing one. And under IT, we've then got production, then Geo Region 1 and Geo Region 2, and then we've got our subscriptions coming in, and then it would go to our resource groups and then to our resources. So our, make sure I said that correctly, our management groups are hierarchical, and we can split this up the way we want. So the closer we get to where the users come in, which is your subscription, the more we can fine tune that. So under IT, perhaps you give more rights, you know, to create resources, but under human resources, you don't give them the rights to create resources. Then under production, you may give additional rights or reduce additional rights, whatever you want to do, and so on. But you've got great flexibility in this here. During the study that I did, I didn't see any questions that went into a lot of detail on this, like why would you have 2 layers of resources? I never ever saw a question like that. The only questions I kind of saw here when it came to things like resource groups and management groups were, could you nest them within one another? And a couple of other wee questions that we'll see as we come up. So the first time I saw this was when I studied this course. I hadn't looked at this before. I had come across resource groups by playing around with Azure Portal, but this is the first time that I've seen this. During this course, you will not be creating subscriptions or management groups. That goes to a higher level than what we've got access to. So all we do is we look at the theory on this. What you will be doing is you will be creating resource groups and you will be creating resources, but not the top level kind of planning of these. And that ultimately brings us to the end of the first day, which is by far the longest, I think, of the talking that I will do, well, hopefully. Next week, we'll be mainly introducing you to the Azure portal and how we set up some of the services on it. I think that's all from my point of view from this PowerPoint presentation. Any questions before I turn off the PowerPoint presentation here? Any questions about that demonstration? Now, I'm not sitting here thinking that, oh, you should remember all 39 slides off the top of your head, but those key parts that I pointed out, I'll put the PowerPoint on in the team within the class notebook. I'll put that presentation in there. So I'll just publish it there. I'll probably just publish it this afternoon, and you'll be able to see it within the OneNote. So next week I am going to introduce you to the Azure portal because we haven't looked at it yet. So we'll start looking at, how would you create a virtual machine? How would you create a database? How could you create storage? How could you create a virtual network? I'm not going to go through all of the things you can do because it would take me a long, long time. But I will point you to the resource that shows you where you can, if you want, practice on about 16 or 17 different things. Basically, what you see on the portal is what anybody else would see, whether you were a company like IBM and they were using Azure or whatever, they will see the same interfaces you have. They'll have a lot more credit and resources that they can pay for, but you've got your £100 worth of credit that you can burn through the course. I think, as Andrew said, you generally spend about £20 of that if you went through most of the things and remember to turn things off. So you've got plenty of credits there to actually practice as we go through. Just going to stop the presentation of that. Ultimately, that's what I will be going over today. What you should do, if you haven't done so already, is register on the Microsoft Learn. And I'm just going to quickly go back and show the team again. So in if you click on General and go to Class Notebook, and I've got this here again, you can do this through OneNote, and the content library, under Resources, This is Microsoft Learn here. You can go and register there. Register with your college or your own personal email. It doesn't matter. This one, it doesn't. You don't have to use the newly created Outlook one. There's some the walkthrough links. So this is what I'll be kind of going through next week. I'm not going to do a lot on GitHub. So that I saw there was a couple of people having problems with GitHub. You can access this without having to register, but it will have a number of walkthroughs that will take you through. Basically, I'll be going through these next week. That's just one link. And for next week, you must have covered at least this. If you can have a look at this, then great. But you must have covered at least this part 1. That covers everything that I've covered today. And it'll get into a wee bit more depth in some of the areas, but it will reinforce everything that I've covered today. What I have done is focused on where you're going to be asked questions within the assessment. I'll give you that part a wee bit more, or where you're most likely. Obviously, I do not know what questions you're going to get, but where you're most likely, from my understanding, to get that. So during the course, I think you will cover at least 90 to 95% of all of the things that you can get covered in the exam. What I noticed when I was getting my practice exams and what I noticed when I did the final exam, and this is the same for all Microsoft exams, there'll still be that roughly 5% of things that's not in any of the materials. That I don't know whether they just try to find the people that have done additional work, but it is really difficult to study enough that you could know that additional 5%. But the things that I've stumbled across during the practice and other ones, I will obviously try and teach you, or dropping off hints in those kind of areas that you should focus in on those. So for next week, the main thing for you is to go through the Azure fundamentals. You don't have to use Azure Labs. I will register for Azure next week and just see whether everything works as it should have. And if it doesn't, well, hopefully we can sort that out next week. And then I will demonstrate the Azure with you. Any questions before we finish off today? Oh, sorry, and one more thing. There's one more before let me just show this here. I want to make sure you see this. Under again, the study guides are useful to help your studying. I'll go through, in fact, I might just go through that right now. But the practice quizzes, I've created 30 questions on that first section. You really should know the answer to all 30. You're not going to know it the first time you go through it, but once you've done that a couple of times, you should be able to get 30 out of 30 on that. And obviously, the closer you get to 30, the better it is. Now, just before, I'm going to just quickly show you this here. I'm going to have to stop this and show it. So what this is, and one of the reasons I like this, was a resource that I used quite a lot. Excuse me. So what this basically does is gives you an overview of all of the sections within Azure. So for example, if I was doing an exam question, and not obviously the real life exam, but within the practice ones, and I got something on IaaS, PaaS, and SaaS, and I couldn't work out what the differences were, or capital expenditure, I would come here, and this would give me the overview of those particular areas. And within the study guides, if I wasn't sure what PaaS is, this would be a particular link to PaaS, but it would have the main contents of its sheet. So study cheat sheet, I don't know why they'll call these cheat sheets. It sounds as if you're doing something wrong. But if you come in here, it gives you the main descriptions of the kind of responsibility matrix and things like that we had within here. So I found this to be a really useful resource when I was going through it. So if there was something like, oh, what was DDoS protection, I could come in here and look at the study cheat sheet and have a wee look through to see if this helped me on that particular question. I don't think I used the practice test so much on here, but yeah, there's a couple of more additional questions that if you do want to go through, I didn't really use as practice questions much, but yep, they'd be worthwhile doing as well. So the more practice questions that you do, the easier it will be. Okay, that is definitely me finishing. I think I've said I was going to do that a couple of times. So Microsoft Learn for next week, and that will basically be it. I'm going to stop the recording right now.